So I'm going to start working on the motor mount install. So the plane comes with no thrust molded into it at all, so we have to figure that out. I'm going to use about 3.5 degrees of right and 1/2 degree of down. So in order to set that and have done these planes, I'm going to make a little jig, and I'm going to use that jig to sort of hold the motor and the motor mount and the firewall all into place. So with the Pletty, I'm going to install Pletty. There's going to need to be a front kind of firewall in here that the motor mount will bolt to, and then really the spinner will just sit outside of this. And you know, this is an 89 millimeter spinner, so it fits pretty close. This is about 92 millimeters across here. If you use a smaller spinner, you just have a bigger gap. So different size spinners will have different gaps. This is an 85, so you see it's a little bit more of a gap in there. And this is a true turn, and it's an 82, so it's even more of a gap. I think 85s look okay. They're not too bad. It does give you some thrust play or whatnot. You could actually recess it in here if you really wanted to kind of do something cool. You know, stick it way back like that. Maybe not quite that far back, but you could stick it back to where the prop sits. But the 89 fits pretty much the right shape of the fuselage, so I think that's what I'm going to go with. Okay, so I'm going to work on getting a template for the firewall. So I'm going to install a Pletty into this with F3 mount, F3 unlimited mount. This mount goes back to when these motors first came out. I designed it, and it works fine for putting in these motors. So there's a few details. This is the thrust washer or backing plate, I guess, that's going to sit on there. So in order to know how to shape the firewall, or really where we're going to put this on the firewall, we need to kind of know what this back dimension is, because if you can imagine, when we put the right thrust in the plane, call the intersection between the thrust plate, thrust washer, and the shaft, you know, the 0. So this, you know, is going to have some right thrust in it. So this is going to sit, you know, just slightly canted. So really, this whole motor mount is sort of shifted to the right slightly, just to kind of keep everything sort of in line. If you just put it all centered and did it, you would end up with your spinner kind of off center. So in order to keep the center of that spinner straight, we're going to have to offset this whole motor a bit. So really, it's not going to be offset too much. But how we're going to do that is you first need to know the distance from basically that point to here. So we're just going to use my calipers, set them out, and just measure the depth of that. And it's about, call it 12.5 millimeters. 12.4, but 12.5 millimeters. So we're going to use some trigonometry, and I know I'm going to have 3.5 degrees of angle in that. So really, that's 3.5 degrees, the tangent of that times your 12.5 millimeters is about 0.76 millimeters. So that's all that this plate off the center of whatever shape your firewall is going to be. So if you basically offset that by 1 millimeter, you'll be pretty close. Now, as you get further and further away, this gets more. So if you were to measure the back of the motor, this is like 78 millimeters, and you offset that now 3.5 degrees, that's like, this back plate will be like 5 millimeters. So the back ring that goes in the back here, this will shift over like 5 millimeters. So it's quite a bit more dramatic at the back, but we'll worry about that later. So I'm going to use that now in making my template. Part of the template is to understand where in the fuse that's going to go and sort of what shape that's going to be. Fortunately, on this fuse, it's pretty round through here. So I've went ahead of time and I've marked off about 12.5 millimeters back from the front of this. So that's, and it doesn't have to be perfect, but that's essentially where this motor is going to sit in here. Right, it's going to sit back, you know, the back of the mounting plate is going to be about 12.5 millimeters back. So that's essentially where our firewall is going to sit, right in this spot. Right? So I've marked 4 spots, and I'm going to take my outside calipers. It's hard getting that camera, but the outside calipers. And really, I'm just going to check at those spots, you know, what the diameter of that fuse is in both top and bottom. And they're about the same. Pretty close. So I'm just going to say that that's a perfect circle. So I'm going to make that firewall to start with in the template a perfect circle, and I'm going to use that diameter. And that turns out to be, in this case, about 107 millimeters. Now, because I'm measuring on the outside, you know, and there's a bit of thickness to these fuses, right? You're probably talking 0.5 millimeter, maybe the front's a little bit more. Yeah, 1 millimeter. So I'm going to take 2 millimeters off of that diameter. So I'm going to call it 105 millimeters or so, and that's going to be the start of my former. So here's my former kind of drawn. So I used a compass to draw the outer circle at 105 millimeters. So this guy is about 105 millimeters. And then I drew my center lines through that point, and I offset the center line by 1 millimeter. It's close enough. I'm not going to bother with try to do 0.7. And then I took my front mounting plate and I lined it up these holes, the center of these holes through my offset line. And then I marked my mounting holes. And I also marked where these cooling holes are going to be. Because what I'm going to do is I'm going to trim that. I'm going to cut this outer. I'm basically going to take my compass here. And I'm going to use the offset center point. So that this entire middle piece where these cooling holes are is not, it's gone. It's not in the way. And that's really my starting template of my firewall. So I'm going to cut this out of this piece here, and I'm probably going to make a balsa piece first, a 1/4 inch balsa piece, because I'm going to use a 1/4 inch light ply for the firewall. So I'm going to cut a 1/4 inch piece of balsa just to match this. Okay, so I got my former made. It's flat in the bottom just because that was the width of the balsa I had. So you can put that in there and test it out. I mean, from a roundness perspective, it actually fits pretty good, but if you take your motor with your mounting plate put on it, you can go through there and go, there's no way that's close enough. So obviously this thing has to come in more. Part of that reason is the fact that the fuse is tapered and this piece is not, so you're gonna have to, usually I start by tapering this thing down and seeing, and then slowly working the fit. So it's really just a matter of slowly but surely working that into place until it gets about right, that when your motor's on the back, on here, and the thrust washers, out on the front of the fuse where, about a bit of a gap there, then at least your firewall is pretty close. Okay, so I worked the former down, took a little bit. It ended up being closer to 97 millimeters in the bigger diameter and then tapered down. So if you put that in the front, you can see that, and this is now mated up to the front of the motor, I got a pretty good spacing there. So it's actually going to set back just a little bit, which is fine. I mean, we'll fill that in with glue nicely. So I'm going to go ahead now and work on the formers to do the alignment. So I'll show you how that's done. It's kind of, I just built a little jig to set all this in place. So I'm going to go ahead and work on those and cut this out of the final material that I'm going to use to mount the motor to. Okay, so basically shaped my former out of light ply. I took a bunch of extra material out of here, just left the ears, and that's really, just so we got some cooling paths around there for the airflow. I didn't drill these all the way out for blind nuts yet because I'm short some, so I'm going to do that afterwards. So the next step is making all the templates. I'm not going to use the motor actually to do the install, so I've made a few of them already. So what I got is this one, and this one really is to fit flush with the front of the fuselage. So it's essentially in there, right on the front of the fuse, just sized, just so it's flush. And then the vertical and horizontal lines are on there, so that'll line up. That gives me the exact center of the fuse. and I drilled a hole, 1/4 inch hole right in the middle of that. I got another one, 16th inch ply. You could make this one a little bit thicker. This is going to basically space this right flat to the back of the fuse, or the front of the fuse. And this is what we're going to use to set the thrust angle. Because in this model, this thrust angle right now is 0, 0. So there's no right, no down. So I'm going to use that. And I'm basically going to screw this piece to this piece so that they're held together. And I've got the offset lines. So yep, I got the offset lines already on this piece. So center of the fuse actually lines up with that line, and it's essentially spaced this way slightly, just to accommodate for that right thrust offset that we talked about earlier. So that's going to sit like that. I did put some relief holes in here if I wanted to put the bolts in to test fit the motor mount plate. So I'm going to screw these two together just in the exact right spot. That way, when this is in there, the firewall is centered on the nose ring piece, but it's also offset. So it's basically got the correct position so that when we put the spinner on, the spinner's centered properly in the front. So I'm going to go ahead and screw those two together. So those two are just screwed together. I just got some flush screws, just drive them in there. You know, those holes in this piece will disappear later. So then how this fits, as you can see, it's slightly offset to the one side. So when this fits in here, we know that basically the center axis of that back plate is slightly offset relative to the fuse. So this is the front flat part. Okay. And since I've lined it up, I know, you know, when these bolts are perpendicular. So when I line this up straight up with the fuselage, you know, I know my motor mount's going to be in there horizontal, so I don't have to worry about that part. Okay. So the next thing then is basically to set this on the front. So this is just a 1/4 inch hole through there. So you can just use a 1/4 inch bolt to hold those two together. Now you could make this out of, this isn't super stiff, so you could make it out of 1/8 inch or 1/4 inch plywood or light ply just to give it a bit more rigidity. I'm not going to bolt it in here super tight. It's just really to sort of set the thrust angle. So I'm going to get my bolt through here, line this up, and I'm just test fitting this to start with. So there. So what's really holding this together is just sort of the friction. That's all that's keeping it from falling out, is just the sheer fit of the parts in the back. So now to set the thrust, you know, all I really need to do now is just shim, you know, one side there, the top and the other side. Now the other side, I'm going to shim this in one side and out the other. So to get 3.5 degrees on that diameter is 2.8 millimeters total. So I'm going to do a millimeter, 1.4 millimeters each side. So basically a little less than a 1/16 of an inch each side. And then the down thrust is 1/2 degree. So that's 0.4 millimeters. So I'm just going to use a real tiny shim just to validate that down thrust is in there. And I'm sure it will be, but that's all it's really going to take. Is there is not a whole lot of down thrust going to be in the model. So that's how I'm going to do that. So I'm going to go ahead and get this shim in the other side here, because I need to put one kind of inside this spacer and one on the edge of the fuse. Okay, so I've seated my spacers on there. So there's the 1.4 millimeter on the one side. This side I'm going to use one, but I'm going to just sort of wedge it in between the edge of the fuselage and that spacer plate. And then this is my 0.4 millimeter one on the bottom. So one question that might come up is, how do you get a 0.4 millimeter spacer? Well, in this case, to sand a piece like this, just a little trick, take one block, take another block, preferably one that's maybe a foam pad, hold them together, and just, you can very quickly sand down a piece of wood. So you just keep doing that till you got 0.4, use your calipers, right? So like this one here, you know, is 1.43 millimeters. So I'm not going to worry about 0.03 millimeters. It's pretty close. So I'm going to go ahead and put this back in here now. And now this time when I put this front spacer on, this should be recessed back slightly and this down. Now this top piece should be flush, and then this side piece should be flush. And then I'll put my spacer in there, which will pull it out. And that'll give me my total offset of 3 millimeters across the entire, you know, that'll give me my 3.5 degrees of right thrust. Okay, so there's our plate back assembled. Now you can see our shim, you know, this is pushing in now. That's why I say this is maybe a 1/4 inch ply might be better. So I'm probably going to just put some tape on here in a few places just to hold it in place. On our other side here, I'm going to pull this out and put my spacer shim in there. So that's just going to give me that bit of offset right on this side. So then I've got it spaced. It's going in on this side and it's coming out on that side. You know, and then double check that your bottom is down. So again, I'm going to put some tape on here just to make sure this is all being held in place tightly. So there, that should do it. You know, so we should have a little bit of down thrust. We should have our correct right thrust. And the firewall should be nice and horizontal in there. So we take one look inside. You know, there's the firewall and the fit. So I'm just going to tack glue that in place for the time being. And then check the fit with the motor and prop. That way we can always pop it out of there and redo it if we're not happy with it. So I'm going to do that, let that cure up, and I'll come back and show you what it looks like with the spinner on it. Okay, so I pulled out the spacer ring and everything, so you can see the former in there now. It is a bit, you can kind of tell it's maybe a bit offset to the right, a bit more gap there than there. So I'm going to go ahead and put the motor mount in and the motor in and just trial fit that spinner just to see, you know, how accurate we got. This is the time to trial fit that. If it's not perfect, you know, you can pop this out, your tack glue out, and fix it before you fully glue it in. Okay, so I tack glued that in place. I got the motor plate back in there and the back plate on. So I've come pretty close. Now I did have to pull this and readjust it one little bit. I had to lower it like just a hair just to get a nice centralized fit. So it's pretty easy to do that if you tack glue it. So you'll notice, you know, on that side there's the gap we set for the right thrust. And on this side you see we're actually back, the spinner back plate's almost inside. So that's the nice thing about these kind of open noses, is you can kind of recess that back. And so with the spinner on, and this is the 89 millimeter, so this is a big one. Normally I don't run the 89 on them, I run the 85, so you'll see it's like she's kind of just a snug fit inside there. So, and if you did want to shim it out a bit, it's really easy to shim behind the back plate on these just to stick it out a little bit more. So that's pretty much the front mount. Now the back one's a bit easier because I just do it when it's right on the motor. So while we're waiting for the glue to set up, we can go ahead and approximate where that back is going to be. Because really it's basically, you know, from the back of the motor here, it's about 60 millimeters where your back ring's going to be. So you can just step off a measurement from inside that firewall to the back. It's in and around this spot right here. So we need to make the little ears that are going to hold our back ring in there, right? So you want to get this shape. So a couple ways to do that. You could take some sticks of balsa and kind of join them together just to sort of form that shape. I use one of these tools. It's just a shape transferring thing. I've already went ahead and done this side here. So you basically just push it up against the fuse, and it transfers that shape onto the little pins. These just move in and out like that. You can get these on Amazon or hardware stores or whatever. So it's a pretty easy way to get that shape. Then from that I traced it out onto some you know, heavy paper, and really that's going to be the shape of our ear inside there. And this I just approximate this dimension. So when we get the motor hooked up in here and set in place. And I put that back ring on. I'm just going to use this in about the right spot, and I'm going to mark off, you know, on those ears where those holes are going to be. And if I got to adjust the template a little bit, no big deal, and then I can go ahead and cut it out in the actual material. So that's how I get the template for the ears at the back, for the back motor mount. Okay, so I got this plate tack glued in here. I did fit this up. We test fit the spinner, so that's all looks good. So now to put the back ears in place, I did cut the 2 ears out of 1/4 inch light ply. I don't have the holes in, which I'm going to do right now. Why use 1/4 inch? The reason why I like to use 1/4 inch is just simply because there's more bonding area where the glue is. So I've used really narrow, and I just find sometimes, you know, it can be hard to get a really good bond to the fuselage where it doesn't accidentally break off if you bump it. So to get these ears in place, we need to set the back ring on the motor and fit the motor into the fuse. So I'm going to put this back ring on the motor here in the right spot, just covering up these screw holes. And then I'm going to fit this up into the fuselage, and then we'll work on getting those ears kind of located and the holes located. Okay, so I got my motor in there, reassembled. I got the back plate ring on in the right spot, horizontal. Motor's bolted to the front mount, and I did put the spinner backplate on just to make sure it's centered. And if you do, like, there's a bit of play in this, left and right and whatnot. So if you do find that maybe, you know, your thrust didn't look quite right, you know, feel free to kind of give it a bit of a push and adjust that, and then tape your spinner backplate kind of in place. You know, the motor's got a bit of weight on it, so it will sort of sink down, giving you a bit of up thrust. So usually you have to pull that back down. So I do have a bit of tape on the down part of the spinner here, just to keep that thrust in alignment. Generally, your right-left thrust is pretty good. So really, for the ears, this part's quite simple. You know, that backing ring is where I want it. So I got my ear here. So make sure you get the one side. So I'm just going to put that in place where it sort of matches up nicely to the fuselage. And all I'm going to do is I'm just going to mark basically in the center of that, you know, where that hole's going to be. So there's that one. So I know if I drill a hole right there, it's going to be pretty much centered on that. And I'll do the other ear now. And because this is the slotted back plate, you know, you do have some left-right adjustment. So there's the right ear. So I'm going to use metric 3, so I'm going to drill these both out for metric 3. And then I'm going to come back, bolt them to here, and then tack glue them in place. Got my hole drilled out. So I'm going to go ahead and put some glue in behind here, right where those are going to sit. I'm just going to use some Hysol 20 HP again. And I'm not going to try to like get it totally glued everywhere. It's basically to tack it in place just so it can't move. And we'll come back, because all this is going to come out of the model anyways for painting and whatnot. So when we come back to do all that work, you know, we'll get all these fillets done at that time. So I'm really going to slide this around here and slide it into place, and then slide my bolt where I want it. Squish your glue around if you need to. You'll line up for your bolt hole, and there it goes through. And I'm just going to take a nut and tighten that down. Just a regular nut, nothing. Don't need a lock nut or anything fancy like that. At this point, we're just trying to hold that in place so it cannot go anywhere. There. So that's the one side. The other side is the exact same process. So I'm going to do that. I'm going to shut the camera off because I need to be where it is. If you do want to clean up some glue, you can. Anyways, we let that set up, both those sides set up, and then dismantle. So one question is, you know, why why I like this. So again, from a maintenance standpoint, to take this motor out, I would pull these two bolts. This pops off backwards, pull my spinner and prop off the front, and then I can pull the metric 4 bolts that are in the motor, and I can take this whole motor assembly right out this way, and I never have to take that front motor ring out. So it's very quick to take the motor out and change it, or do any maintenance to it or anything like that if you ever need to. So that's why I have it assembled in this fashion. I found it works pretty good. So there are motors done. You know, the next day overnight, those ears have set up nice. So I just fit up a prop and a spinner just so you can see kind of the gap. So the way I've done it here, you know, is I do have a bit of gap on this side just due to the right thrust. And then on the other side, on this side, you know, that spinner's actually sitting back in behind here a little bit. So that I've done it that way just to minimize that gap. You could have this pulled out a little bit further. You'd have more gap on this side. If you're using a contra, you know, that's obviously going to be 0, so it won't matter. And this is the 89mm spinner, so it does work. If you're using like if you find a full 92, you know, you'd have to space it out a little bit further. If you do want to make the fuse match up, you know, feel free to do that. I just never know, if you sell the plane, someone wants to use a contra, they want to use a Pletty, you know, then this way it kind of works for both cases. There's our back mount. You know, I still have to do the fillets and whatnot inside here, but other than that, it's basically ready to go. So I do those fillets all kind of at the end, when everything else is finished, and I just do everything in one shot. So these are the parts. I'm going to use Falcon gear. Pascal does have his own gear that he can include in the kit, but I got other planes with Falcon gear, so just to make it simple from a replacement standpoint, I'm going to use them, and they do come nicely kind of pilot drilled with some holes, so you can easily get the gear, swap gear legs and whatnot if you ever need to. So these are the parts that come in the kit. So this is the plywood mount for the gear itself and the two formers. The formers do come like so. I've gone ahead and, you know, cut this bottom piece out here just to save a bit of weight. I don't know, so a few grams. It's not a ton, and they fit nice together. So you really just, you know, need to assemble them like this, glue them up, and stick it in the fuse. So it's a pretty straightforward assembly. Now, you can go ahead and laminate these with carbon if you want. Basically looks cool. I don't think it really gives you any incremental strength. I've done these just with the stock parts right out of the kit, and I've also laminated them with carbon. You could laminate it and really cut probably more lightning out of them, but you know, I prefer to have a nice strong gear assembly. You know, just I fluff grass, so you just never know. You hit a bump or something, you don't want it tearing out. So the first thing I'm going to do really is I want to mark the holes on this plate and get them nice and straight, and then that way at least the gear legs are you know, set up on here, and they're drilled properly. So I'm going to go ahead and drill out all the holes in the gear first. Okay, so I went ahead and drilled my gear out. There's the 3 holes, and I also drilled the axle out. I do use these axles. These are also of Morris Hobby. They're steel, they're not the lightest, but they're got a bit of a spring on here, and they got a little bolt in the end to capture the wheel pant. So these really just, you know, this piece goes inside the wheel pant and then threads on the gear, and then this piece goes from the outside of the wheel pant and kind of captures the wheel and the wheel pant all in one assembly. And with the spring on it, it keeps the wheel from rattling, so your wheel just sort of sits in between these two washers. They only work with certain types of wheels. Tetra, you can get them to work with Dubro, but it's a bit tricky. Anyways, very good. So I've drilled out the gear for both those. So the next step's really to sort of locate it on the plate. So I've kind of mocked one up. I've put center lines on both sides of the plate. So because the gear has this center line already molded into it right there, And that center line is lined up with this middle hole, so you can see those are kind of in line. And it goes out, you can kind of see where in the light there, where the gear starts to transition into the curved part. So this mold line goes past that. So really the flat part of the gear sort of ends, a little bit past this bolt here. So what I do is I line up this center hole here with the center line, and then I flip it around so I can just barely see. I don't know if I can get it in the light. There it is. I can just barely see that outer mold line, and I line up with the center line on the other side. So now I know the gear is centered, and it's basically on the flat spots. When I bolt it down, there's no gap in here. It's a nice flat surface that you're bolting against. So then I know that that's straight. So I'll do that for both sides and mark off these holes, and then I know where to drill out the plate. Now it does end up with the holes, these bolt holes not being real far in, but it's fine. It's just your blind nut might be just right up against the fuse, but really most of your stress is kind of in the center anyway. So okay, so once you get that all assembled and the holes marked off, you can go ahead and remove them, and then drill out those holes. I'm going to use the same diameter as this for the time being. Make sure you get the plate marked which way is forward and kind of top or bottom, whatever, just so you get the right orientation in the fuse when you go to put it in. So once you get them all drilled up, you can dry fit them up here. I got a couple bolts in there. Everything lines up real nice. So you can see how that turned out. That's the advantage of the Falcon gear, is it just, with those pre-drilled holes, it makes it super easy. So I'm going to go ahead, I'm going to glue this together now. And all I'm going to do is I'm just going to CA this with medium CA for the time being and clamp it all together. And then when I go to officially glue it in, I'm going to fill it, in these corners here, top and bottom, and then I'll glue this whole assembly in here. So right now I'm just going to medium CA all these together, clamp them so they're square. I'm going to get your square out, try to get these things as square as you can to the plate, and so that they're parallel to each other when you're gluing it, and then we can start fitting it into the fuse. Okay, so the next step is the fuse is marked with where the gear is going to go through, so I just highlighted it in a pen, and we're going to grind that out, and that's going to fit where the gear is going to fit in there. So it's going to sort of establish the location of where our formers are going to go. So I'm just going to cut these out with the Dremel tool. So those holes are cut out now, both sides. I'm trusting that Pascal has those fit or in the right position, I guess, the correct location. So I didn't double check them or anything. I just cut them exactly where they are. So we're going to see how that fits here in a minute. So I got my former in here. Now I have to trial fit this in here. It does fit okay. I did have to trim up, just sand off a little bit along the edge there. Just so it's not pushing on the fuse, but it drops in there nicely, and it does fit. Basically you line that up in between those, just centered on those slots, and it does fit quite nice on those slots. So the gear actually on both sides slides over it. So if we throw the gear on here, it's still a bit of a tight fit, but it does slide over top. We're going to have to do some adjustment to the slots on the outside. There you go. So that's just sort of a real initial fit. So that's essentially how that gear former's going to go in there. So I'm going to go ahead and keep tuning these slots up and working the shape just a little bit, and then we're going to get ready to start gluing that former into place. Okay, so I'm ready to glue the gear former in. So I've marked, where I'm going to glue lines. You can't really see in the black, but you can see them after you mark them. But I've marked them all the way up, so I know I'm going to run high sol with the static mixer. I'm just going to put a bead of glue on there and everywhere, and then just slide that former down into place. I'm also going to go and glue, put a fillet in, on all these sides as well onto the gear plate before I put it in there. And then I'm just going to sit it in there, align it to those slots, and weigh it down overnight. So my fillets in the corner, you know, top and bottom. Some high sol, and there's all the fillets around where the gear is going to go. So I'm just going to slide that in on top now and just squish that glue out. Make sure you're getting this in the right way that you had it oriented before. So once you get that done, you can then go clean up those edges if they need them. Maybe add a bit of glue where you're a bit short, just to create a nice fillet. Okay, one last thing, we'll just set a bit of weight on it, just to make sure it's nice and squished down into the fuse in the right spot. Double check your sides each way, that they're even or close to it. And that's it for the gear plate. So now that the gear's in, we really just have left to do the axles and the wheel pants, which I'll do next, and then that'll finish up the gear assembly. So while we're waiting for glue to dry and whatnot, we'll go ahead and get the axles and the wheels. So again, use these axles. These are steel, and some Tetra wheels. These are 55 millimeter, so 2¼ inches maybe. You can use the 60s, but I find they're maybe just a hair bit big for these wheel pants, the Falcon wheel pants. So the 55s, if you kind of see where they sit, 60s pretty tight in there. So I like to use these 55s. If you use the 60s, they do fit. I've used them, but you got to grind some stuff out of here. So just something to keep in mind when you're doing, if you're going to use 60s. So I'd already drilled out the hole in the gear, so the next step really is to drill out the same hole into the wheel pant, because this here is going to sit inside that wheel pant like that. So I'm going to go ahead and drill those out on the drill press for that. Okay, so we got those holes drilled, pretty straightforward. Falcon, they give you a dimple where to drill that, and that matches up, nicely with the gear and where that goes together. So that is the one nice part about these gear are well designed. So I'm going to test fit this out a little bit. I'm going to take this end screw as the retention screw for the wheel pant. So there's actually that screw and a small little washer that captures the spring, and then the spring itself. So let's go ahead and throw the wheel in there. So the wheel, these also need to be drilled out a bit. They're not quite, this is I think, it's a 156, so 5/32, so it's about 4 millimeters diameter shaft. So this does need to be drilled out just slightly. So I'm going to go ahead and drill these out so they fit on that axle nice. So we got these drilled out. I drilled out with a .159 bit. So those fit in there nice, and they're no slop in there whatsoever. So these wheels go on like this. So this is why not all wheels work, is because the Tetras are recessed slightly. They're flush on one side and recessed on the other, so they can't go on this way. If they go on this way, you're going to obviously rub your wheel pant quite badly. So they need to go in that way, right? So that sticks out, right? Gives you some clearance, and then that gives you some space in here for the spring and the washer. So essentially these would fit in there just like so, right? And then that would capture the wheel pant. But first things, we're just going to throw these in here and bolt them up to the gear and see how they look. So there they are. So that's why I like these axles, because A, they're quite simple, and they line this up real nice. So right off the bat, we're pretty close. Now, you'll notice the way these wheel pants are is they're kind of crooked. It almost is like relative to the axis of the wheel, that wheel pant's heading that way. So I actually want to kind of hold these like this when I go to mount where that screw is, right? So I'm going to try to position those a little more straight down the wheel, and that way I don't have any, you know, accidental contact back here or here on the wheel pant. And then for rotation, I don't really do anything because of the lip on the Falcon gear. You know, really this can't, it can rotate a little bit, but it's pretty fixed there, so I don't even bother with that. So really, we got to locate where that screw is going to be, and relative to, you know, us holding that thing slightly in position. So I'm going to show you how to do that. Okay, so I'm going to mark where that is on the wheel pant. Is you first got to locate the end of that axle. So what I did here is I just clamped the gear to the table, and I clamped just a piece of heavy paper to the table, and all I did is just mark where the end of that touches and just put a little hole in there, and I'm going to use that to mark the wheel pant. So I'm going to put the wheel pant back on here and just let my paper ride in there, and then I'm just going to mark that with my pen, and then I know exactly where the end of that axle is and where I have to drill the wheel pant. So get your wheel and wheel pant reassembled. Put some tape on the outside of the wheel pant because you need something to be able to draw on. So then put this back on here, and then we're going to mark our hole. So I got my wheel pant back on there. So all I'm going to do is, again, I'm going to make sure that it was positioned the way we wanted it. And I'm just going to put a mark right through this paper here. Alright, so we got our mark on our wheel pant. So I'm just going to go ahead and drill through that to capture that washer. So this is the washer you need to drill. Now, it's kind of difficult to see, but there's actually two diameters there. There's the inside one, which matches the axle, and there's a very subtle ridge there, and that one's going to capture the wheel pant. So, you know, that one is 0.236, and that one is 0.173. So I'm going to drill for that 0.236 one, so that part actually, and that allows actually the spring to be pushed in from outside the wheel pant. If you drill it smaller, you can't get the spring in from, and you have to kind of put it in with the wheel, which makes it quite a bit more difficult. So this way you can just put this whole assembly in from outside the wheel pant, and then it captures the wheel pant. So I'm going to go ahead and drill that hole into the wheel pant. So I got that hole drilled, and like I say, it's just, so it does sit nice and flush with that little recess, right? If you didn't have that, it would sit a little bit out, so it sits in there nice and flush. So I'm going to go ahead and work on this assembly. So I've got the inner washer on the axle, wheel on with the indented part on the outside. I'm going to put the other washer on here, and then I'm going to throw this into the wheel pant. Pops through there. So there's my axle protruding through. So I'm going to throw my spring through here. Throw this guy on the outside of the spring, and then I'm going to compress the whole thing and tighten it down with this screw here. We're going to basically get this on the gear. So now I do find sometimes these wheel pants are a little bit narrow, so you know, they might not quite get out to the edge of that washer depending on just their exact fit, but that's fine. In the heat and whatnot, I'll probably move a bit, then just tighten this guy up. So that's really it. At that point, you're done with the wheel pant. There's the wheel, nice and free, and the whole assembly's done. So repeat that for the other wheel, and then both the gear are finished. So I got the gear put back on the plane and just lightly bolted up to the fuse. So that's how it looks sitting up on its own wheels. You know, our wheel pants and everything, you know, turn out pretty good. You know, nice and free on the wheel. So like I say, that setup works pretty slick. And so the stock position of the gear, lots of ground clearance. You know, here's a 22-inch APC prop, 2213 actually. You know, so there's tons there, and even when the model's sitting up kind of on step. And then this a 23-inch Falcon Contra. So for the Contra guys, you know, biggest Contra props, no problem. You'd have to tip that thing pretty far over. So that's how they work. So that's basically wraps up the gear assembly. There's not much else there to do other than a bit of tidy up on my blind nuts down the road.